you so much for having me here in the FoBI workshop. My title is called Large Language Models in Social Media for Urban Housing Livability. So I wanted to start with why we have to look into occupants' voices on their social media and why we care about people in the buildings. So to me, I think humans are the direct services of buildings, right? We're actually having workshop in this conference room, and I think I heard a bunch of complaints yesterday saying this room, it was too cold for many of us. We had actually to put another jacket over us. But traditional way that we try to understand how people feel or how people think about the buildings are majorly through two approaches. One is called questionnaire, right? We can deliver the surveys or questionnaires to the building occupants, basically to ask, do you have any complaints, anything that you think we should improve? Are you happy with the temperature set point? Do you feel too cold or too hot in this room? But it's very costly, and you cannot actually scale it up, right? Because you need to deliver the questionnaire to each person in the building, and if you wanted to have the long-term, understanding about the indoor temperature or all those heating, cooling performances for your, right? It's going to be very labor intensive in that way. And the other way we're going to approach this is through sensor measurements. It's going to be expensive as well. Just to think about how many rooms we have in this building and how many, stories we have in the building as well. We have to deploy different sensors to measure, temperature, humidity, even lighting, right? All kinds of, parameters we care a lot for the people living or sitting or working in the buildings. And also lacks of, explanation and, answers for why, the CO2 carbon dioxide, jumps up, or why people are turning fan or having their portable heaters or coolers, right? It's very hard to get all kinds of this response of using sensor measurements. So, and when it comes with building performance evaluation, including indoor environmental quality, energy, carbon footprint, we have to leverage both traditional approaches to understand, how can we make buildings better and let it perform in the right way for the building occupants. And in the other side, right, humans are also the major drivers or the primary influencers of building energy use. So think about if we are happy with the room, right, we don't have to adjust our lighting, we don't have to turn on the HVAC. Most of the behaviors or actions we're having or interactions we're having with the building elements because we're not happy with the environment that we are given with all kinds of HVAC systems that we're providing. And that means if you feel not satisfied or happy with the environment, it tends that you're going to have some kind of energy usage behavior, and that would actually cost additional energy costs in terms of your, the utility bills, or you have to, use more energy in terms of that. That's why, the behaviors that we care a lot or all kinds of interactions we're having with the building elements really influence a lot with building energy usage. And the other concept that I wanted to put here today is we have to acknowledge that we are the good sensors. We know what will be the best temperature for us. We know what will be the good time to put on another sweater or, or just wear a t-shirt. So we just, the best biological sensors that, all kinds of other sensors cannot achieve. And we also inclined to report our impressions, and we are happy to actually leverage, the category of sensor networks we're having so that we can actually leverage both IoT sensors and the human sensors together. So I think that's actually the future direction way that we should have both humans as the sensors, but also IoT network to measure environmental performance. So that list was actually the main topic I wanted to touch upon today, where I think all kinds of complaints or the alternative way we can have with the questionnaire and service is we're going to leverage tons of abundant open-ended data we have on social media. It's all user-generated. We can freely talk about whatever we wanted to complain about the buildings. It's going to be a lot of data that openly, publicly available. So that's why, how can we really look into social media data that generated by the user and then to extract meaningful information that we wanted to learn about the building performance for the people. And as I mentioned earlier, right, the social media data would give us a lot of open-ended. It doesn't like questionnaire. We have a bunch of questions listed over there asking specific perspective. But for social media data, you can write anything that you want it to be. And it can be very abundant and sufficient and massive data, large-scale data available on social media. And you can just develop, all kinds of understandings with, the topics that you're interested in. But to me, it's going to be like indoor environmental quality complaints, or whether the building is working for you or not, and what kind of actions that people are taking inside of the building, given the environmental factors. And also the other side of, leveraging social media data is it's going to be unsolicited reviews. Like most of them are actually unsolicited or unstructured reviews. So that means, right, people can write anything that they want to say about the buildings or anything around them to be posted on social media. And often they're not having any rewarding system to freely express their opinion. So that means, right, it's going to be an alternative approach for surveys and questionnaires because, most of the, human subject recruit projects, you actually have to provide some kind of incentives for the human subject recruitment. So in this way, right, I feel like we should actually leverage or at least take advantage of the open-ended, massive, abundant big data available on social media. And this slide I have is I wanted to emphasize that a lot of data we're having, they're actually big contextual data. A lot of information embedded in textual data, and it requires another set of machine learning or the other way to really extract information or retrieve information embedded in textual data. Is going to be a little bit different from time series data or the numbers that we have been dealing with all the time. That's why it comes with large language models. It's kind of relatively new and topic, and it has really recent advancement with large language models, LLM. I have this map here. Just wanted to give everybody a sense that since 2019, right, how many large language models rapidly evolve. With the Google, with Amazon, with all kinds of startups, with OpenAI, right, it really becomes the most wealthy, startup firms right now. I think everybody probably is using ChatGPT like it's our best friend right now. So over, right, past, 7 years or 6 years, I just listed some of them are widely, acknowledged or used LLM models over there. But there are tons of them I didn't list here, and it's actually from a paper. But the problem with all this recently developed or kind of popular, widely used LLM models, the problem for them is they are all pre-trained based on, as I listed here, right, web pages, books, news, scientific data, code, or fictions, or Wikipedia. Most of them are actually cross-sourced or trained all this LLM model based on the web pages. So to me, if we wanted to leverage LLM models for building application, the problem is how can I actually fine-tune or adjust all this pre-trained LLM. They have very limited data or knowledge about buildings, but I can train the LLM models with the building domain knowledge, so it can act with an expert and perform what I want it to be for the building domain adaptation or for building application. So what we did here for the project specifically is, of course, I'm very interested in working with the social media data and try to understand, how we can have meaningful information or meaningful insights that we have to learn about the building complaints through the social media. So what we did is we really look into Airbnb and Booking.com as actually two platforms right now for social media data because they offer the temporary residences, and we can understand about how people really think about the building performance in Airbnb and Booking.com. And we scrapped 60 major cities by population across the globe, and that actually gave us 22 million reviews. That's a lot, actually, data to deal with. And then we only look into English written reviews because, I don't speak Spanish. And unfortunately, we just wanted to make sure that, the field data would be actually perfectly related to building related performance. So we removed the other languages. We only kept English written reviews, and we ended up having 13 million reviews in our data set. And then in this project, we particularly, fine-tuned or work with BART, which is come with a two-part. One is called BART encoder, and the other is GPT decoders. There are so many LLM models available, but we're particularly looking into this because it comes with three features. One is it's called zero shot learning. Basically, if we are not having enough training data set, right, we don't have enough label data set to fine tune the large language models, then it's better that you have zero shot learning so that, any, testing data set are not seeing any data available in training data set, the zero shot learning would be able to do that. So your model still can learn in the way that, your testing data set doesn't have the label data in training data set. And the second reason we pick up this large language model is it comes with contextual learning. I just wanted to provide example. For example, many of the previous, large language models development, they really look into word embedding. For example, we talk about bank, right? It really learns about the bank, but it doesn't look into the context before bank or after bank. I'm just giving an example. But for example, if the post is talking about bank robbery, right? We wanted to detect all this information, but the previous LLM model cannot actually perform the in-textual learning. But BART is actually the first one, and I think is still consistently performing very well for the in-context learning. So that means it's not learning the word itself, but also learning the context that the word is putting. So in this case, they're going to learn from bank robbery rather than just learn, bank and robbery. And then third reason we pick up this one, it also has the self-attention mechanism. So that means they will place the words in different positions in the reveals and trying to understand, whether the sequence of having the words in that contextual learning would matter a lot or whether it would affect different, situations and how the model can actually extract more information here. And then what we did is, right, we have to develop the domain-specific, information. How can we equip large language models with the domain knowledge? So what we did is we developed something I call it a semantic dictionary. Because LLM pre-trained on fictions, Wikipedia doesn't have building knowledge. So we develop a semantic dictionary. We have, a group of experts coming together to label some of the data and also come up with some of the keywords that, we think that usually people would touch upon all these topics. But, as I said, this is going to be zero-shot learning. So the testing data set doesn't have to say what we ever feed here into the model. It still can perform what we don't have in the semantic dictionary, but it's actually the first step to fine-tune the large language model or the pre-trained LLMs a bit better. And then we also apply the other classifier. It's called natural language inference. We kind of modify BART structure a little bit because we wanted to make sure it has, in-depth building knowledge so that it can perform what we wanted it to be. So the natural language inference, what it did is you have to come with a hypothesis. You're gonna provide a post and believe either it's agree with each other or it's neutral or it's completely reject the hypothesis. And that means, right, as the name suggests, it's called inference. So that means if the model doesn't understand about what you're saying in this post, it still can infer, right, whether the post will be related to the topic or not really. So the NLI, the classifier, we're stacked with the BART structure is really doing the work that, just in case the training data set doesn't have enough, information we wanted it to be, and it's just add another layer to make sure that the model can have the building domain knowledge, can act as the building expert. So what we did next is we fine-tune the model, right, with all this, classic, optimization function down here and try to minimize the differences or discrepancy with every epoch that you're trained with your training data set and your testing data set to make sure that, all these hyperparameters running with the, deep neural network really works over here, and that's very classic. But we actually have the iterative loop here to make sure that if the data doesn't understand or if the BART structure is not ready, then we're going to fine-tune the hyperparameters on all these layers together to make sure that, the output layer can really have the building domain knowledge. And then once the structure is over, we actually have the social posts, right? fit into the structure, and we will look into two levels. One is, I call it the whole post level, and the other is we break down the longer post, or many of them might write a paragraph, write comments on that. And then we split them into different sentences. So we fit them with one called post level classification, and the other I call it as sentence level classification. And then that's where we're going to give every sentence a label, and also the whole post a label too. And then the whole motivation of this project is we wanted to understand, whether people are happy or not happy, or what kind of behaviors they will be taking inside of buildings. So we apply another model, which is called Roberta model for sentiment analysis. Basically, this is ranging from -1 to 1 is continuous variables, giving your idea whether it's actually extremely satisfied or extremely dissatisfied. And that would actually provide your geocoding, services as we stack another module with the Roberta model for sentiment analysis. So this is kind of results we're having here. This is your ongoing project. We have more results coming along the way. And I don't want to touch upon all the details we're having here, but just try to have like a little bit high level, information here. And we classify the building complaints according to different categories, and then try to map, what kind of, like, which country or which cities they're actually experiencing major problems. And as you can tell, right, most of them, they're actually in grayish or greenish color. The box plot really means that people complain about the air quality a lot inside of the buildings, and tends to make more behaviors to actually reduce the air inside, like indoor air pollution problems. And some of them, they're actually marked as the red, and that's pretty much about the thermal complaints, right? They're not happy with the thermal environments that they're having inside the buildings, right? They might adjust their thermostat, and they might do, the other interaction with the building elements. And then we also rank cities and countries to make sure that is it below expectation or above expectation, and what would be the specific problems that they would be. So I won't touch upon a lot of details on this graph, but I wanted to show another, a good approach that I like using LLM to really look into textual data, because it would really give us a lot of unique sources that we never imagined before for the livability concerns. For example, we realized that dog barking is really a problem for people who actually try to work or sleep in their buildings. We realize kids can make a lot of noises that people complain a lot, and footsteps and fire alarm. So all those, unique sources that we wouldn't be able to identify with questionnaire surveys or sensor measurements, but we could actually use large language models to help us identify all those resources that we never imagined before. And it could provide us more, specific targeted interventions for the future to understand how the buildings can perform better. And it's very interesting that we have 99 negative reviews in Las Vegas, specifically talking about fish. And that really led me to understand why fish really be a problem in Las Vegas. And I looked into all those reviews as I copy paste to here. They said the room smell like a rusted fish. The bathroom smell like a weird fish smell. And I realized, most of, the temporary residences we're really looking into in Las Vegas, they either have the fish ponds in the indoor spaces or next to the lake, or fish shop or restaurants around Las Vegas. I never visited Las Vegas, but I realized, to think about if you're actually managing the buildings and think about how to mitigate the concerns for the building occupants, then, at least in Las Vegas, right, there are 99 negative reviews, extremely negative reviews talking about fish as actually the source for their livability concerns. And then I also, there's another layer that I like. You're saying large language models for understanding building performance for the people, because we can start with the complaints, right? People may complain about their quality, complain about their thermal comfort or their thermal environment, but we also could understand what would be the sources to contribute that complaints. So I'm just to take an example. For example, it would be, air conditioner. But air conditioner could be associated with the noises, overheating and overcooling concerns, and we can really map this out with the textual data we get with the social media. And then you either can do, right, you can understand, okay, if we have these complaints and then we understand the sources, then we can really understand what behaviors that people would take to mitigate the concerns. For example, you can turn off AC, or you can use the window, or some of them, they prefer to just adjust the thermostat. So I would like to conclude that we would like to incentivize the high performance people, right? So we're looking for alternative solutions inside of the buildings, not just try to use additional energy usage inside of buildings. So I think we have to really think about how we get the data and turn that into a reward system, so we can incentivize more high performance people inside of high performance buildings. There are so many debates that we need more high performance buildings here today to minimize energy usage, but I wanted to argue that we also need high performance people inside of high performance building too. And the other research that I've been doing, in addition to understand why people try to use more energy inside of building and how can we make them happy inside of the building, I think it's also necessary to advance the infrastructure resilience. As long as, during power outage or during extremely hot days, if the built infrastructure can provide more resilient for the building occupants, then we don't have to look into all kinds of energy usage behavior inside of the building. And then I think the other way that I approach this is we have to really facilitate cross-disciplinary research. I think as many of you have been doing in your lab and with your team. And we are actually cross-disciplinary research lab as well. My lab is called Laboratory for Healthy Environmental Resilient Lab. And we have, a bunch of people from data science, robotics engineering, neuroscience, and public health. We all come together to understand how buildings and cities can be significantly improved to understand or to improve climate resilience and health outcomes. And then this is actually the last slide I have here. I wanted to resonate with what I have been emphasizing in my talk. I think we have to really think about what will be the occupant-centric buildings, and we have to listen to their voices and their complaints so that we are making sure the building is performing the right way for their people. And of course, we need more data. We need new methods. We need new technology to collect the data. And I think large language models just represent the new way to understand what we should to hear about their voices. That's it for my talk. Thank you so much.
Thank you.